Alrighty, in today's notes, we are going to talk here about classifying triangles, and we're going to talk all about the triangle notation by sides and by angles. So the reason that I'm assigning this as something for you to watch as a screencast is this is something you've been doing for years. And so as we look through these, the goal of these notes is that you can just reestablish the vocabulary. There's going to be a couple things specific to our context. And then when we come back next week in class after you watch this at home, we're going to practice some of this to secure your knowledge. So let's review, starting with classifying triangles by their sides. So the first way that we can do this is our first type of triangle is going to be a triangle where none of the sides are the same length as each other. And I want you to think for a second here if you can remember what that is going to be. And it is called a scalene triangle. S-C-A-L-E-N-E. A scalene triangle is a triangle in which no two sides are congruent. So none of our sides are going to be congruent to each other. One of the best ways to be certain that triangles are scalene, if we're just trying to use markings to show this, is if we sketch for ourselves. So remember that it didn't work here. If you draw a shape on the iPad and hold it, if it's a triangle, it should straighten it out, which is a great feature added in the last couple of years. And then to show that you know the different sides are different lengths, you can use like 3 different tick marks. So one side with 1, the other with 2. So tick marks can be used to show things congruent. It also helps us indicate and compare size measurements. This shows that they are all different. All right, so that is our first type of triangle. Next up, we are going to move on to the type of triangle that's shown here, where there are 2 sides congruent. And there's going to be a little bit more vocabulary, a little bit more detail with this one. So next up, we have an isosceles triangle. Hopefully you remember this word. An isosceles triangle is a triangle in which at least 2 sides are congruent. So at least 2 sides. Typically, isosceles is just going to be 2 because we have an even better word if all 3 are congruent. But if all 3 are congruent, it is technically under the category of isosceles. So looking here, we're going to use this example. So it says triangle DEF. And in triangle DEF, sides DE and DF are congruent. In this case, when you have an isosceles triangle, the 2 sides that are congruent are going to be called the legs of the triangle. And then the third side that is not congruent to the other 2 is called, so EF in this case, is going to be called the base. So we have a leg, and the third side is the base. It doesn't always have to, we think of things sitting on a base. It doesn't always have to be on the bottom of the triangle. It's just the third side that is not congruent to the other 2 pairs. Okay, next up, not only in isosceles triangle do the sides have special names, but so do the angles. So in my triangle here, I'm going to switch to this color. If you go across from these 2 legs, that's going to give us angle E and angle F. And those, so that's going to be here and here. They will end up being congruent, so these arcs work okay. These are going to be called the base angles. And D, so this top angle up here is called the vertex angle. So these words are going to be very important for you to recognize because when we refer to an isosceles triangle, they're going to pick some of these key words to tell you which sides are congruent. So for example, if they told me that I have a triangle, actually let me write this with a symbol. If they say, let's see here, triangle ABC is isosceles with vertex B, that means that if I think about drawing a triangle, I'm going to kind of straighten this out here. And if I want to think about it having, sorry, this is going all over the place here. There we go. If I think about it having 2 congruent sides, typically you're going to see it like this. Then I need to fill in my letters. that means that the angle the angle that's formed by your two legs at the top, that in this case is going to be B. So that means the other 2 points making those our base angles are going to be A and C. So what that clues us in is now we know which two sides are congruent. That means AB has to be congruent to BC. Otherwise, we wouldn't know without this information. Okay. So we've got so far scalene triangle, isosceles triangle, and this is by sides. The last one is going to be if all three sides are congruent. Hopefully you are familiar with this term. That is going to be equilateral. So an equilateral triangle is a triangle in which all three sides are congruent. So equilateral, lateral is the word for sides. I would assume Latin, but I'm not an expert on that. And then equi is equal, so equal sides. Equilateral. So we've got scalene, isosceles, and equilateral. Those are the three different ways to name a triangle based on comparing its sides. Now let's go ahead and let's look at angles. So next up, we're going to classify triangles by what types of angles it might have. So in this case, we've got a couple of different types. One is an acute triangle. An acute triangle is not just a very cute triangle, haha. It is a triangle in which all three angles are acute. So all three angles have a measure that is less than 90 degrees. So let's make an example for ourselves. Let's see here. Let's say that this angle is 40 degrees. This angle is 60 degrees. Let's do some quick math. That's 100, so that means this third one has to be 80 degrees. All three of those are numbers less than 90. That's going to make this an acute triangle based on its sides. Interestingly enough, since all angles are different, that's going to end up, we'll make connections later, it's going to make all of the sides different. So this would be a scalene triangle, but the main thing we know about it is that it's acute. All right, next up, we know these triangles. We know and love them. It is the right triangles. So next up, we have a right triangle is a triangle in which there is exactly one right angle. There is exactly one right angle. And in the Ed puzzle, it's going to pause here in just a second and ask you to answer this question. I want you to think a right triangle can only have one right angle. I want you to think about what you remember about the angles in a triangle. And I want you to, about the angles in a triangle, and I want you to type in for me some explanation of why is it impossible for a triangle to have two right angles. So I want you to think about the question, why can a triangle not have two right angles? So it's going to pause here. I want you to give me your best ideas, and then we're going to keep going. Okay, hopefully you give me a great answer to that question. Now let's keep going. So with the right triangle, we have some notation. Hopefully, again, this will bring back prior knowledge, and we're going to use this a lot more as we continue. So when we have a right triangle, the side that is opposite my right angle is called, switch to a better color here, it is called the hypotenuse. This is super important. So this is always going to be the longest side of our triangle, always longer. The sides that actually make up the right angle are the legs. So if I have a right triangle, the two sides that form to make that right angle are my legs. So we have a leg, we have another leg, and then the side opposite my right angle is always the hypotenuse. Alrighty, let's keep moving. Next up is we've done acute, right? What other type of angle did we have? We've got obtuse angles. So an obtuse triangle is a triangle in which one angle is obtuse, only one. So we only need one of the angles to be obtuse. And in fact, whatever reasoning you gave for why you couldn't have two right angles is probably going to apply here, because more than one obtuse angle, numbers don't add up, cannot form a triangle. So let's draw ourselves an example. That worked pretty well. You want to make it obtuse. You want to make one of those angles look like it is bigger than a right angle. So draw it kind of nice and wide angle. The rest of them are going to be skinny. So let's say that I'm going to make this a little bit bigger for myself here. Let's say that this angle at the bottom is 120 degrees, and maybe this other one is 20. Angles have to add up to 180, so that's going to make this other guy 40. So two of the angles have to be acute, but the other one is obtuse. That makes this an obtuse triangle. Alrighty, last but not least. So we've got the three types of classifications of angles go for classifying triangles. So acute, right, and obtuse. The one last classification is going to actually match, and we'll talk about it, with similar to a side classification. And this is the case where all of the angles in a triangle are equal. So here we go. This one's hard to say. An equiangular triangle is a triangle in which all three angles are congruent. So an equiangular triangle is a triangle in which all three angles are congruent. Try saying that word. You'll probably struggle. It's not easy to say, which is why we have a better catch-all word for that. Here is the deal. An equilateral triangle is going to be also always going to be equiangular, and vice versa. So for only equilateral triangles, the words are interchangeable. So you are very rarely in a proof going to hear me refer to a triangle as equiangular, where pretty much across the board, most mathematicians refer to it as equilateral because it's just a little easier to say and it's more common. But let's think about this real quick. If I have, and it didn't straighten out here, we're going to do our best to draw. This looks pretty equilateral. We're going to say mark all three sides to be congruent. Next question that I want you to think about is if a triangle is equiangular, or if it's equilateral, all angles are going to be equal. What would the measure of that be? So I want you to think about it, write it down, see what you can figure out. We'll touch base on that when we get back into class next week. Okay, so here's what we got. You can classify triangles both by their sides and by their angles. So when we classify them by their sides, we're looking at how many of the sides are congruent. None, two of them are congruent, or all three. For angles, we want to look at what types of angles our triangle has and use that to classify, is it acute, right, and obtuse. And we can mix and match angle and side classifications to give our best description of a triangle. Okay, so you might be thinking, cool, that sounds great. What do I actually do with this? Now we're at the point of this section where we're going to work through some examples. This is where the pacing of this is up to you. I am going to go through these different examples in this video, but if you feel comfortable with this classification and you would like to give these a try on your own, be my guest. Pause the video, try them out, and if you want, you can fast forward to the place, or you can watch forward to the place where I show the answer. I'd encourage you try it first, and then you've got the video to go back if needed. There's two problems and there's a proof, and that's what these notes are going to cover. Okay, so let's look here. This problem here is telling me that VSY is isosceles. This means that two of these sides are going to be congruent to each other, and its perimeter is less than 45. It's saying which side of VSY is the base. So if VSY is isosceles and its perimeter is less than 45, which side of VSY is the base? All right, so the question itself indicates for us that we do not know which side is the base, so that means I don't know which sides are going to be congruent. So here is what's going to happen. There are certain math problems that at the beginning do not have an immediate answer. We're going to have to do some guessing and checking actually and test to see what happens. So there's a couple of different ways that you can organize, but there's at least one key piece of information, and that is that this is a very small highlighter. There we go. That the perimeter is less than 45. Remember, the perimeter is the sum of all of your sides. So that means adding up our sides here, 10 plus x plus 7 plus 2x minus 8 has to be less than 45. So that's kind of interesting. Let's clean this up and see what we can figure out. Let's see here. 10, 7 minus 8 is 17 minus 8 is 9. So that gives me 3x plus 9 is less than 45. Now, let's solve this for x. Let's see what x has to be less than. So 3x has to be less than 36. So that means x has to be less than 12. Okay, awesome. That helps us. We now know a key piece of information that x has to be less than 12. But how does that actually factor in to our problem? Well, we'll see. If you feel like sparked with creativity, take it away, see what you can figure out. If not, keep watching. Let's see what we can find. Well, now we're going to do some testing. We're going to test the different sides as bases to see what happens. So let's suppose that SY was the base. If SY was the base, the side on the bottom, that means that VS and VY would be congruent. So that means x plus 7 would have to be equal to 10. That means that x would equal 3. Okay, well, I mean, that looks pretty promising. Well, if x is 3, let's see what happens. So if x is 3, that means VS, we already know that's 10. That means VY is 10. And SY is 2 times 3 minus 8. It's 6 minus 8. SY is negative 2. Oh no! That's a negative side. That means that doesn't make sense mathematically. I can't have a negative segment when we're working with a triangle. So that means SY is not the base. So let's keep going. If SY is not the base, I'm just randomly guessing here. I honestly haven't looked at this since last year, so I don't know which side's the base. So we're just doing this as we go. Let's say VY is the base. If VY was the base, change our markings here, that means that VS and SY are congruent. So that means 2x minus 8 equals 10. That means 2x equals 18 and x equals 9. Well, that satisfies our condition that x has to be less than 12. That seems promising. So let's see here. That gives me a side of 10. That gives me another side of 18 minus 8 is 10. And then 9 plus 7 is 16. This looks super promising. So it looks like, based on this information, VY could be the base. So VY could be the base. So we most likely have our answer here. What I want us to do, just to be extra careful, is to try the other side and see if something wacky happens. If not, it's possible that this problem could work 2 different ways to satisfy a perimeter less than 45. Let's see. So far, I like this one because all the numbers make sense. They match with our conditions. Let's try, what's the third side? VS. If VS was the base, that means that x plus 7, these sides would be congruent, equals 2x minus 8. See here, that means that 15, add the 8, would have to be equal to x. Aha, that does not work because our condition for perimeter is that x has to be less than 12. So that means that therefore we're going to use our 3 little dots. The base of triangle VSY is segment VY. Oof, okay, that's a fun one. Okay, if that's the case, we now know the two legs are 10, base was, I think that was 16. Okay, so that is one way to use this. Alrighty, next up, number 2. We've got some expressions here in a perimeter, and our goal is to show triangle ABC is scaling. So we want to show that if I solve this problem out, no sides are the same length. Let's see if this happens. So now that we're trying to show this is scaling, let's label these sides. So AB is x plus 3, AC is 3x plus 2, BC is 2x plus 3. Okay, so here's the thing. Now is where our keywords show up. The perimeter is 20. That's another piece we haven't used, and we want to show that this is scaling. That means that none of these sides should be equal, so I can't set any of them equal to solve for x. So this is where our perimeter is going to come in to save the day. That means we can add up all three sides, and that all those three sides expressions together added have to equal 20. So that means x plus 3 plus 3x plus 2 plus 2x plus 3 is equal to 20. And let's see here. We have 6x plus 8 equals 20. That gives me 6x equals 12, so x is 2. Alrighty, so here is your task. Now I would like you to use this. We know x is 2, so this has to somehow help us determine that this is indeed a scaling triangle. So next questions that Edpuzzle is going to ask you in 3 questions. I want you to use this to find your 3 sides, and then I want you to use the Edpuzzle to select the answers you found or to type in your answers for the different links so that I can see what you got. And then from there, we are going to move on to the next problem. Okay, so hopefully you've typed in your answers now. Here's how you would complete this to show it. Once you have this, you would want to say, so something like, you found your sides, and so now I would say something like, since AB equals 5, BC equals, I'm doing this math real quick, 8, and, oops, that should be AC. AC equals 8, and BC equals 7, no sides are congruent, and triangle ABC is scaling. So this would be a way that we can complete our answer. We can actually show that we know we're connecting the knowledge and we know why it has to be, and that says scalance. Let me fix that. We know that it has to be scaling. All right, last but not least, we are going to prove a triangle is isosceles. So let's look here at what we have. So we have OT, this guy here, bisects segment GM. So it is being cut in half, even though it doesn't look like it. ME bisects GO, and angle 1 is congruent to angle 2, and TO, this whole segment here, is congruent to EM. All right, so I want to prove GOM is isosceles. I need to somehow prove that that triangle has 2 sides that are congruent to each other. Based on my guess, it feels like it's going to be these 2 sides that meet at G, but it doesn't specify. So we're going to see what we can do. I'm going to walk you through this proof, and especially if you felt confused with overlapping triangles, I'm going to show you the different things we know and build this into our proof. So here's what I got. There's a couple of different ways once you get to the point of working with overlapping triangles, but what I notice is that this side and angle 1 forms this triangle right here. And if I flip it around, the other triangle that has angle 2 in a side is also going to match. So I can prove some triangles congruent that are overlapping. And once we do that, we're going to start there and use that to prove the triangle is isosceles. So I am going to write, just for the sake of time in this video, givens. Okay, here's what we got. So I could prove these two overlapping triangles, so it's EMO and TOM, if I have one more piece of information. I have a segment, an angle at the corner here, and I need this overlapping side. I could prove that congruent. So I could start this and say OM is congruent to OM by the reflexive property. And that is going to now make my two triangles congruent. So that is EMO is congruent to TOM by side angle side congruence. Okay. So here we go. Now, let's think about what is going to be helpful for us here. If we have two angle bisectors, multiplication property, division property, how could that be useful? Well, looking here at CPCTC, I could prove TM and EO congruent. If I could double those with multiplication property, I've got the two sides of my big triangle. We are good to go. So that's going to be our route that we are going to take next. So what was it helpful to prove these triangles? It's those two segments there, TM congruent to EO by CPCTC. So these segments here are congruent. Now here is the thing. Multiplication property says the halves of two segments, if I double them of congruent segments, those doubled segments are going to be congruent. So that means for us here that GO is congruent to GM by multiplication property. So now I have shown my triangle has two sets of congruent sides. So here's how we prove something isosceles. And then we are done with the notes, done for the day. Now that I've shown this, I can say GOM is isosceles. And let's go back to the definition. If a triangle has two sides congruent, then it is isosceles. So if a triangle has two congruent sides, it's isosceles. And there we have it. So when we come back to class this next week, we are going to work with these, do some more problems, do some more proofs. So if you felt confused on any of this, go back in the video, rewatch portions, make sure that you have some solid understandings of our classification so that you can use these this next week. And that is it.